welcome to today's Physical Sciences lesson. My name is Dimpo Rampora, and this lesson is brought to you by the Northern Cape Department of Education in collaboration with Pakama Research and Development. For today's lesson, we are going to be looking at the revision on chemical change, and specifically we are going to be zooming into the types of reaction. And this part of the section of the work, it's normally plus or minus 20 marks that you have in the previous question papers. You can check your previous question papers, but we are going to zoom into acids and bases, and normally this is question 7 from previous question papers rather. Now, before we can get into today's revision, the following are the lesson objectives for today's lesson. You should be able to define an acid and a base according to two scientists or according to two theories, which is Arrhenius as well as Lonry-Bronsted theories. You also should be able to define the terms ampholyte, hydrolysis, equivalent point, as well as endpoint. You should be able to distinguish or differentiate between strong acids and strong bases, as well as weak acids and weak bases. And you should also give us examples, right? You also should be able to distinguish between concentrated acids and concentrated bases, or dilute acids as well as dilute bases. You should be able to write down the reaction equations of aqueous solutions of acids and bases, and also you should be able to identify the conjugate acid-base pairs for given compounds, right? You should also be able to write down neutralization reaction of common laboratory acids and bases, and you should also be able to determine the approximate pH, which could be equals to smaller than or larger than 7 of salt and salt hydrolysis. You should be able to motivate the choice of a specific indicator when you are dealing with titration. You should also be able to perform stoichiometric calculations based on titration of strong acids with a strong base, or a strong acid with a weak base, or a weak acid with a strong base. And these calculations are going to also include what we call percentage purity, which is what you did in grade 11. Right, it doesn't stop there. You should also be able to explain the pH scale as a scale of numbers from 0 to 14 used to express the acidity rather, or alkalinity of a solution. You should be able to also do calculations of pH values of strong acids as well as strong bases using this formula, which is pH is equals to minus log concentration of hydronium ions. Okay, that is the correct way to write it. The 3 is supposed to be a subscript. Now, with that information that we said that you should be able to do, you must not forget that this chapter you have done it in grade 11, and some of the stuff that you did in grade 11 will be repetition again in grade 12. Okay, now what is it that you should know, or you would know already from your grade 11 in this chapter? You should know already how to define an acid and base according to the two scientists. You should already know by now how to identify the conjugate acid-base pairs from a given compound. You should be able to know by now how to describe a substance that can act as an acid or can act as a what? As a base. You should by now know how to write down the names and formulas of common acid as well as names and formulas of common bases. You should know how to write reaction equations for the dissolution of acids and bases in water, right? You also should know by now how to write the overall equations for reactions of acid with metal hydroxides, with metal oxides, as well as metal carbonates. All right, you should be knowing all of this from grade 11. It doesn't stop there. You should know how to describe an acid base indicator as a weak acid or either as a weak base, which color changes take place when there is a hydrogen ion concentration, or when there is an OH that is supposed to be an OH minus over there. The minus must be an exponent. Ion concentration in a solution changes. Okay, then you should also by now know how to identify the acid and base that are needed to prepare a given salt, and write equations for the reaction. You should be able to write down the neutralization reaction of common laboratory acids as well as bases. So as you can see that this chapter is a continuation of what you did in grade 11, which we are just adding a few things, but the rest of the things that you know in grade 11 are still the same in grade 12. Now, before we can go any further, the following are the exam tips that I want us to look at when we are dealing with this chapter. Now, we do know that we need to know or familiarize ourselves with verbs, the action verbs, as well as their meaning. What is it that the examiner wants you to do when they give you certain action verbs, okay? When the examiner says to you, you must define what is it that you are supposed to do. You must give us a precise meaning of the word. You must actually, or a phrase as concise as possible, okay? As concise as possible. So you can actually give us the definition as it is from the exam guideline. Now, you should also be able to know what, when the examiner says to you, explain, what is it that the examiner is actually asking. So when the examiner says explain, it means that you have to make something very clear or easy to understand by describing or giving information about relevant facts about that particular section. You should also be able to list. So when the examiner says to you, list, factors that are affecting rate of reaction, or list what are the common acids and common bases that you know. So you should be able to give a sequence of names or other brief answers with no elaboration. So when they say list, you don't need to elaborate anything. You just give us the names, okay? Each one clearly separated from the other. So that's what list actually means, right? The examiner can also say state, okay? So when they say state, what is it that you need to do? You give us a specific name, you either give us a value, or you can give other brief answers, okay? So no supporting arguments that is supposed to give us, no calculations are necessary when the examiner says to you, you must state, okay? So when they say to you, apply, okay? Apply this and this and this, what is it that the examiner is asking you? It's actually saying that use an idea, use either an equation, use a principle rather, or use a theory or a law in a new situation. All right, that is what apply means. Then calculate. Calculate means that you need to find an answer using mathematical methods, okay? You don't give paragraphs, you don't give explanations, you don't list, but we want to see mathematical methods when the examiner says to you, you need to calculate. Further, the examiner can say to you, describe, okay? When they say describe, you need to give a detailed account, including all the relevant information. So when you're describing something, you don't leave anything out. You give details, all right? That's what a describe means. The examiner can also say differentiate between common acids and strong acids, or strong acids and weak acid. So you need to be able to know what the examiner means when they say differentiate. So it's to give differences between two or more different items, okay? You need to tell us what is different about this and what is different about that. Distinguish. When we are distinguishing, we are actually showing similarities as well as differences. So as you can see, there is a difference between differentiate. When you differentiate, you are differentiating between two or more different items. Those items must be different. But when you are distinguishing, you are looking at the similarities as well as differences. And then estimate here is when you find an approximate value for an unknown quantity or used in the information provided and the scientific knowledge, right? And then lastly, the examiner can say to you, identify. So when the moment the examiner says to you, identify, what is required for you to do, you need to find an answer from a few possibilities that the examiner might have given you, all right? Now, without wasting any more time, we are going to move on from the action verbs. Now we are going to look at the structure of the question paper in this section of the work under acids and bases. How is the structure of the exam in this topic, right? Obviously, there's going to be a multiple choice question. Okay, where you're gonna find it, the multiple choice question is going to be in question 1. Is normally multiple choice question, so you should be able to know how to answer multiple choice questions. Obviously, there should be also definitions, and we are going to look at the definitions that are associated with this chapter, and then you should know each and every definition, because you don't know what the examiner is going to ask you. Also, you should have a background of stoichiometry calculations that you also did in grade 11, that you did in grade 10 to solve a stoichiometrical calculations. There should be, it's either you're given a concentration, you have to convert it to number of moles, or you are given a volume, you have to convert it to number of moles. So we will be dealing with stoichiometric calculations. We will also be doing pH calculations, because in this chapter we want to know if the solution will be acidic or basic. The examiner can say to you, calculate the pH. Okay, you also are going to be doing titration calculations, and this is normally plus minus 4 marks, depending on how the question is structured according to the examiner. And then lastly, the investigation type of question. So under acids and bases, you could be investigating the relationship between strong acids and weak acids, or you could be doing a titration experiment, and the examiner actually likes that question where they are asking you about titration and what does it mean, what is the investigative question, what can you use as what can you say as a conclusion, what could be used as a controlled variable. So those are the things that you need to familiarize yourself with. Now let us look at more exam tips. Now, what is it that I'm tipping you about when you are doing this question? Now, I'm going to advise you to have a mind map. You know, having a mind map explores what you know, and you can compare it with what you don't know, you know. So you can just quickly make a mind map for yourself around this topic and say, what do I know about acids and bases? So I've already done the mind map for you. So the mind map will assist you to see if you have touched on everything that the exam guideline is saying about this chapter. So as you can see here, what we are going to be focusing on, or what this topic is focusing on acids and bases. And you should know the definitions of acids and bases according to Arrhenius and as according to Lowry-Brostand. Okay, so according to Arrhenius, remember, he's saying that an acid produces hydrogen ions or hydronium ions in aqueous solution, and a base is produces hydroxide ions in aqueous solution. All right, but in the other hand, Lowry-Brostand, remember, says that an acid is a proton donor and a base is a proton acceptor. All right, as you can see, so now I have already covered the definitions under acids and bases, but I should know that there are different types of acids. Remember that we also did the differences between strong acid as well as weak acid, and the differences between strong bases and weak bases. Now, in a strong acid, remember what happens. The acid ionizes completely in aqueous solution. Remember, an aqueous solution is a solution that consists of water, right? And then a weak acid will ionize incompletely in aqueous solution. All right, and then a strong base will dissociate. Okay, they dissociate completely in aqueous solution, and a weak base will dissociate, or it can ionize incompletely in aqueous solution. So please, you need to know the differences between a strong acid, a strong base, you know, and you know the different types. Okay, we'll look at the ones that you must remember. Then also on your map, on your mind map, you look at the differences between concentrated acid and concentrated base, diluted acid and diluted bases, right? You have to look at titration calculations. Here we said we are going to basically look at stoichiometry calculation. We are also going to be looking at neutralization reactions of common laboratory acids and bases. So all of this, the mind map will help you to see if you have covered everything as you study and prepare for your exams. And hydrolysis, remember, it is the reaction of salt with what? with water, and then the pH scale and the pH calculations, and which formula you must use when you are dealing with the pH calculation, and as well as how to identify the conjugate acid base pairs, right? So from just drawing your mind map, this is going to assist you to see if what is in the exam guideline is actually outlined in your mind map. I hope the mind map is going to assist you. Another exam tips that I want to give you in this chapter is that you need to familiarize yourself with the list of strong acids as well as strong bases, weak acids as well as weak bases, right? If you know the differences and you know. Now, another exam tip that I want to give you is you must make sure that you familiarize yourself with this table. Remember, we've spoken about strong acids and strong bases, weak acids and weak bases. Now, what is important is for you to know the names and the formulas of strong acids and strong bases. So if you know this table or familiarize yourself with this table, then you're not going to go wrong when you are dealing with this chapter. Now remember, your strong acids, you have your hydrochloric acid, you have your nitric acid, you have your sulfuric acid, as well as your phosphoric acid. And then your strong bases, you have your sodium hydroxide, potassium hydroxide, lithium hydroxide, as well as barium hydroxide. And if you look closely, you will see that how do you identify your strong bases? You look at Na, you look at potassium, you look at lithium, you look at beryllium. They are all elements from group 1. So all the elements that are in group 1 that can react with a hydroxide, you know that they are going to form strong bases. Okay, I hope this is going to assist you. Weak acids, we have your acetic acid as well as your oxalic acid. It's important to know both the formula and the name. And here we have our weak acid, which is ammonia, as well as zinc hydroxide. All right, this is the table that you need to make sure that you familiarize yourself with. Another exam tip that I want to give you the differences between concentrated and diluted. All right, if you can master the different types of acids, strong acids, weak acid, or strong bases, weak bases. If you have mastered the names of those different types of acids and bases, the next thing that you must master is identifying or understanding what does the word concentrated mean and what does the word diluted mean. Now remember that if you have a concentrated acid or a concentrated base, you actually have a large amount or the number of moles of the acid or the base in the proportion of what? Of water. As you can see here, I tried to bring in the diagram to assist you to see that. As you can see here, we have more of the acid than the water. But because we have more of the acid than the water, then we say that your solution is concentrated. So when we say something is concentrated, we mean that we will have more of the acid or more of the base in the proportion of water. And there is more of the acid than the water in the solution. Like I've said, there is a large amount of the acid in the proportion to the volume of water. And another thing, diluted will then mean that you will have more of the water than the acid or more of the water than the base. All right, that is what we mean when we say this is a dilute acid or this is a dilute base. Now, what you must take note is that you must not make this mistake. This is a misconception rather. You thinking that because a strong acid is strong, it will become weak when the solution is diluted. No, remember that strong acid will remain strong acids. Whether they are concentrated strong acids or diluted strong acid, it does not change the strength of the acid. All right, so the word diluted and concentrated only just means that you have more of the acid more than the water, then it's concentrated strong acid. Diluted strong acid will be more of the water than the acid, but that will not stop the fact that the acid is strong. I hope you understand that. Another misconception is that you might think, or most of you think, that a weak acid becomes stronger when the solution is concentrated rather. That is not the case. Okay, a concentrated acid, it can be a weak acid it can be a strong acid. What we actually mean is that you have more of the acid than the water. It has nothing to do with the strength. I hope you guys will be able to remember these most misconceptions and not take them to account when you are dealing with the examination. You must please don't do this mistake of thinking that a strong acid will become weak when it is diluted. No, diluted just means that you have more water than the acid. It does not change the strength of the acid or the strength of the base. I hope that one will assist you. Another exam tip that I want to give you in this topic specifically, remember we said that the examiner can ask you an experiment type of question, and normally it can be a titration. So you need to know the processes about titration. You need to know what titration is. You need to know what are the materials, okay, or apparatus that we use for a titration experiment, right? You can see here you have a burette stand. There is your burette stand over there, and then you have your burette. This is your burette over there, and then you have your Erlenmeyer flask, right? And then what will happen? You will put either an acid on your Erlenmeyer flask, and then you can put your burette, your base in the burette, and you are really trying to just find the concentration of the unknown using the concentration of the known. That is basically what titration is about. What you must know also is an acid-base indicator is used to determine the end point of the titration, and you must be able to choose the correct indicator for this titration, right? Remember, in order for you to choose the correct indicator, you need to know what is reacting with what. Can you see now the importance of that table of strong acids and strong bases and weak acids and weak bases? It comes in handy when you are dealing with titration. Now, which indicators must you know? There are 3 indicators that you must remember. You have the bromothiamine blue, you have the methyl orange, you have the phenolphthalein, which are the 3 indicators that you must know. However, you need to know when to use which one when, okay? So here I've said, in order for you to use bromothiamine blue, that means you must have a strong acid reacting with a strong base, all right? And remember that the pH range will range from 6,0 to 7,6, which will mean that the solution will somewhere next to be neutral, okay? Why? Because you have reacted a strong acid and a strong base. And which indicator are you going to use for this titration? You must use the bromothiamine blue. Remember, when you are reacting a strong acid with a weak base, okay, which indicator are you going to use? You are going to use methyl orange indicator, which means that your solution will be acidic because you have a strong acid reacting with a weak base. And then your pH value will be less than 7. So it must range between your 3,2 to 4,4, okay, somewhere there. So these numbers can vary. All you need to know is that for something to be acidic, it needs to be less than 7. So, or we can say in this example, it can be less than 6,0. Then another indicator that you need to know is phenolphthalein, which you use it when you are reacting a weak acid with a strong base. And as you can see, the pH change color, or the pH scale, will be between 8,2 to 10. So depending on the type of acid that you are reacting with, the type of base that you are reacting. But what you must remember is that the acid must be weak. It can be any weak acid, or it can be any strong base, all right? Like here in this example, I've given you an example for a titration of sodium hydroxide. Remember, sodium hydroxide is a strong base, and it will react with what? With hydrochloric acid, which is a strong acid. So for this titration, because you have a strong acid and a strong base, the indicator that will be suitable for you to use will be the bromothiamine blue, okay? And the equivalent point for the reaction of a strong acid and a strong base is approximately 7, okay? It can be 6, something to 7, but close to 7, you know that is a neutral solution, all right? Now that we have looked at that exemptive of knowing the apparatus of titration and knowing which indicators to use. The next thing is that I still want you to know the indicators, but I want you to know the color changes, because the examiner can ask you, what color change will the reaction be when it reaches an end point? So you need to know the different color changes that will occur in different indicators. Now remember, we said the bromothermal blue, it will range between 6 and 7.7 or 7, something, because the solution will be neutral. Okay, so when it's neutral, if you are using bromothermal blue, the bromothermal blue in an acid, it will give you a yellow color, but in a base it will give you a blue color. All right, so depending if in your LMAF flask you have put an acid or you have put a base, the color will change into either blue or yellow, right? And then phenolphthalein, you use it, remember, for when you have a strong base reacting with a weak acid. Now the color of this indicator is colorless in an acid, and then it will turn pink when it is reacting, when it is in a base. All right, and then the other indicator is the methyl orange, which you know this will be, you'll use this indicator when you are reacting a strong acid with a weak base. Right, now the color in the acid will be red, and then in the base it will be yellow. So it's very important for you to know all the different colors that the indicators will give you when they reach the end point. All right, when we are doing titration. I am done with that one. When it comes to the different types of indicators that you're going to use, I hope you can still remember that. Another exam tip that I'm going to give you, remember we said that in this chapter we are going to be looking at stoichiometry calculations, where we will be calculating in titration, we will be calculating the pH, right? So what is it that you need to do when you are doing this stoichiometry calculation? Step number one, rather, you should be able to write down the balanced chemical reaction for the reaction. So if they've given you the reaction already, what you need to do, you need to make sure that the equation is what? Is balanced. If the equation is not balanced, then you need to balance the equation. Then you need to convert the given information. Which information? The concentration or the volume or the mass. Okay, where do you convert it to? You convert it into number of moles. So the moment you see mass, convert that to number of moles. You see concentration, convert to number of moles. You see volume, convert to number of moles. All right, and then use the mole ratio to move from the number of moles of the known to the number of moles of the unknown. Remember, where do you get the mole ratio? You get the mole ratio from the balanced chemical equation. All right, I hope you guys still remember how to deal with stoichiometry calculation, because in this topic we are going to do a lot of calculations. We will see. Now the following are the common errors, right? I'm still on your exam tips. The common errors that are learners or you guys are doing when you are dealing with this question. Number one, you confuse the differences between a strong acid and a concentrated acid solution. Remember, a strong acid, we said that it ionizes completely in aqueous solution. Now, a strong acid can either be concentrated or diluted. So whether it is diluted, it doesn't change the fact that it's a strong acid. Whether it's concentrated, it does not change the fact that it is a strong acid. But a concentrated acid only means that you have more of the acid than water. Okay, so that is the difference between the two. So don't confuse strong acid with concentrated acid solution. The next one is you forget the importance of the solvent. Remember here, the solvent is water. C is equals to N over V. This is the volume of what? Of water. So our solvent is water. So when we say it's acidic, when we say it's concentrated rather, or when we say it is diluted, we are talking about how much acid you have in the proportion of water. So the volume, we talk about the volume of water. Please remember that. And another thing that you are confusing in this chapter is that an acid is something which you can eat its material away, or which it can burn you. I know most of you, we watch a lot of movies, and when you think of an acid, you always think about those strong acids that can eat away material, those strong acids that can burn you, okay? But not all acids are like that. Remember, there are strong acids, there are weak acids. And one of the weak acids that we use every day is ethanoic acid, which is vinegar that we use every day in our home. So as we can see, that some of these things are just misconceptions. Testing for acids can only be done by trying to eat something away. It does not mean that for you to check that this is an acid or this is a base, or this is a strong acid or this is a weak acid, you need to test it on a material that can eat it away. No, we need to know which acids are stronger, and we already know that which acids are weaker, okay? It does not mean that it must eat something away. Like when you put vinegar on your clothes, it is not going to eat away your clothes, okay? So I hope you guys are understanding all these common errors and misconceptions that we come to when we are dealing with this chapter. Another one is neutralization, is the breakdown of an acid or something changing from an acid. Remember, neutralization reaction, what is important is for you to remember that the products are always salt plus water, okay? So your neutralization can form a neutral salt, or an acidic salt, or a basic salt, okay? So it doesn't mean that you are breaking down anything. I hope you understand, and we are not taking those together into the exam room. You are also forgetting to multiply the concentration of H2SO4 by 2 when you are calculating the pH. Remember that sulfuric acid, which is H2SO4, is a diprotic acid, and it is, it is a strong acid, and that means that it ionizes completely in aqueous solution. So all of the concentration of H2SO4, whatever that you are given, you must multiply it by 2 because it can be able to donate 2 hydrogens, okay? And it dissociates completely in aqueous solution. Not realizing that the definition of pH is simply the pH equation. You know, the pH equation is pH is equals to minus log the concentration of hydronium ion. So that is basically the pH, and the pH can vary from 0 to 14. So remember the pH scale from 0 to 7, that is acidic, from to 7, that is neutral, above 7 to 14, towards 14, you know that the solution is basic. All right. Getting confused with the conjugate acid base. Acid has an extra hydrogen, just add and remove the hydrogen. I know with this one, you know what, we are confusing how to identify the conjugate acid and the conjugate base. We think that the conjugate acid, it is going to pair with your acid, and your conjugate base is going to pair with your base. It cannot be like that. Remember that your acid will pair with your conjugate base, and your base will pair with the conjugate acid. Not sure which acid is the strongest, okay? Especially when you are given the Ka values, okay? The Ka values will tell us if the solution is acidic or basic, all right? If you have a lower Ka value, will indicate that the solution is acidic. A greater Ka value will mean that the solution is basic. Adding water to a solution doesn't affect the moles, just the concentration. Yes, the number of moles of a substance will remain the same. That is why we are saying concentrated and strong acid is not the same thing. Strong acid means that the acid is strong because it has more, the number of moles are like that. They are strong. And then when we are talking about concentrated, we are talking about how much acid do you have in the proportion of water, right? I hope these common errors, you are going to look at them, and you're not going to do them as you practice your previous question papers. Another one is the student often have an idea that the Ka is just another scale like the pH scale, or it kind of actually tells you similar things, like the lower the value of the Ka, the more acidic the substance is. So Ka is not really a equilibrium, like in chemical equilibrium, or like in what you call in rates of reaction, where you need to calculate the Kc. No, we are actually looking at how is the pH scale in relation to the solution that we are given. Is the Ka value greater? If it's greater, it's basic. If it's lower, it's acidic. Students often say they don't know what the Kw is. This is the equilibrium constant of water. They confuse it with the Kc in chemical equilibrium. I think I've already touched on that, and it's true. Is water is neutral at the pH of the concentration of hydrogen plus will be equals to the concentration of OH minus in the Kw value, which is the equilibrium constant of water. But this one, you need to understand that it only is this equilibrium of water is equals to the concentration of hydrogen ion multiplied by the concentration of OH minus, can only be like that when the temperature is at 25 degrees Celsius. And you'll see when we look at the formula, the different formulas that we have, why do we say that on the formula sheet is also specific. Confuse hydrolysis reaction and neutralization reaction. No, hydrolysis reaction is the reaction of salt with water. Okay, you are reacting the salt with water, but neutralization, your products are salt and water. So please do not confuse the two reactions. Lastly, the examination tip that I want to give you is that you need to familiarize yourself with the formula sheet. Why? Remember, we said we are doing stoichiometry calculations and we'll be doing pH calculations. So it's very important for you to know which formulas are you going to use to deal with acids and bases. Remember, we use all these formulas to calculate number of moles, to calculate the volume, to calculate the concentration, sometimes to even calculate the mass, okay? And then this formula over here, the tip that I'm giving you, you use this formula when you are dealing with titration, okay? So the keywords will be titration, endpoint, a standard solution. So all those keywords, when you see them in the exam, just know that this is the formula that you need to use to calculate that. And then that is the formula for pH. We all know it. And then lastly, this is the Kw that I was talking to you about, to say the value of Kw is 1 times 10 to the power negative 14 at a constant temperature of 298 Kelvin, which is also equivalent to 25 degrees Celsius. All right, you need to familiarize yourself with these equations because these are the equations that you're going to be using. So let us now look at the terminology that you are going to be using, or that you need to know when you are dealing with this chapter. I'm not going to read through all the definitions. I'm just going to indicate to you that you must know how to define an acid according to Arrhenius, a base according to Arrhenius. Lowry, you need to know how to define the acid and the base. You need to know what is a strong acid, what is a weak acid, what is a strong base, and what is a weak base. All right. And then you should also know how to define concentrated acid as well as concentrated base, dilute acid as well as the dilute base. You also should remember an ampholyte. It is the substance that can act as both an acid or a base. Hydrolysis is the reaction of salt with water. I think I mentioned that one. Equivalent point of titration. It is a point at which the acid or a base has completed reaction with a base or an acid. The end point of titration is the point where the indicator changes color. So do not confuse the equivalent point with the end point. The equivalent point, it is the point at which the acid or the base has completely reacted with a base or an acid. Then the equivalent point, it is the point where the indicator changes color. Which indicator? Those three indicators that we spoke to you about that you must know. The ionization of constant water, which is the Kw, which is the equilibrium constant of the ionization of water, and the standard solution, we need to know that it is the solution of a known concentration. And normally when we are doing titration, remember we said we are dealing with a known concentration. We are trying to find out the unknown concentration. Right, now that we have looked at all the definitions, you must make sure you know them in this chapter. Let us quickly look at the multiple choice questions, okay? These multiple choice questions were taken from previous question papers. Let us see how the questions can be structured. Remember, we said we will start with the multiple choice questions as part of the structure of the examination when we are dealing with this type of topic. Now let's look at the multiple choice question. It says the solution that will have the greatest concentration of hydronium ions if complete ionization take place. Now what you must remember, the key words over here is greater concentration hydrogen ions if there is a complete ionization. What comes into your mind? If I am producing hydronium ions, that means I am an acid. So I must look for an acid here. So as I can see here, that is an acid, this is an acid, that is an acid, that is an acid. So all of them are acid. The next keyword is says complete ionization. So complete ionization, now we look at the strong acids and the weak acids. So remember, strong acids, they ionize completely in aqueous solution. So that means here we are looking at a strong acid. So that takes CH3COH away because this is ethanoic acid. So that means D will not be the correct answer. Why is D not the correct answer? Is because ethanoic acid or CH3COOH, which is also known as vinegar, is a weak acid. Okay, so here we are looking for strong acids. Here I have hydrochloric acid, as well as H2SO4, which they are all strong acids. So all of them are strong acids. Now, if all of them are strong acids, what is the key that will help me get the correct answer? It must have a concentrated. When something is concentrated, that means the concentration of the solution must be higher, right? Then it is concentrated rather. You have more number of moles of the acid than the water, all right, in the proportion of water rather, right? So we check here, how much concentration for A of H2SO4? I have the concentration of 1. The concentration of hydrochloric acid is 1. The concentration of hydrochloric acid here is also 1. What is the difference between C and B? Their volume are not the same. But what are we interested in when we speak concentration? We are interested in the concentration of the solution. Remember here, where the concentration of H2SO4, because it is a diprotic acid, it is going to do what? To ionize completely, which means that it's going to donate 2 hydrogens to water to form a SO4, 2 minus plus hydronium, which is H3O plus. So here, because we have donated 2, we must take the concentration and multiply that by 2. Remember when we said that, when we are dealing with SO4, we forget to multiply the concentration by 2, because remember that H2SO4 is a strong acid and it must ionize completely. Now, when we multiply that by 4, it's going to be by 2 rather, is going to give us 2. So the concentration of H2SO4 will be 2 mole per decimeter cubed. So which one between H2SO4 and hydrochloric acid has a higher concentration? H2SO4 is the one that has higher concentration. So the correct answer will be A. So A will be the correct answer. B and C are not correct because HCl is a monoprotic acid. It can only donate 1 hydrogen, right? So you can't multiply it by 2. It will be 1 multiplied by 1, which will give you 1. Let's go to the next question quickly. It says, which one of the following is not a typical reaction of hydrochloric acid? Is not. Let's look at A. It neutralizes a base with the release of hydrogen gas. This is not a typical reaction of hydrochloric acid, because a hydrochloric acid can do what? Can react with a base. When it reacts with a base, it is not going to produce hydrogen gas, but is rather going to produce salt plus water. So this is not the correct one. So if this is not the correct one, therefore this is not a typical reaction of hydrochloric acid. So the correct answer will be A for me. Let us check why B is not correct. It forms hydronium ions in water. Yes, hydrochloric acid is a strong acid. When it reacts with water in the solution, is going to form hydronium ions, which is H3O plus. So this one is correct. This is a typical reaction of hydrochloric acid. Now, it colors the litmus paper red. Yes, it will color red because it is an acid, and an acid, remember, it will turn red in the litmus paper. It forms carbon dioxide when reacting with a metal carbonate. Yes, that is true. When a hydrochloric acid reacts with a metal carbonate, one of the products is going to be carbon dioxide. So that is why the correct answer there is A. All right, guys, I hope you are still with me and you are understanding how do we deal with the multiple choice question. We deal with the multiple choice question. What is the first thing that I've done? I looked at the keywords on the statement. From there, you eliminate the incorrect answers. Then you choose the correct answer based on your knowledge. Now that we looked at the multiple choice question, when we come back, we are going to look at more exam questions.